Hello everyone and welcome to Van Tech Corner. In this video, let's take a look at the Orange Pi R1 Plus LTS router. So Orange Pi have just sent me the two little devices. This one is the Orange Pi SBC and this one is the casing. So let's unbox and see what is inside. We can see that the Orange Pi R1 Plus LTS come in a plastic. This is the EDS shield, so let's just open it up. Beside the router board, you will also have the 13 pins header. So let's put it aside and let's see what else do we have. Yes, we have regulators, compliance, and some certificates. And that's it. Next, let's take a look at the case. Right, so first of all, we have two small screws. And then the case, very nice logos on top of it. It looks solid. Okay, so we can see that it was made of aluminum alloy and it looks very solid. So this is the covers or the back plate or whatever you call it, and a thermal pad. Now let's take a closer look at the R1 Plus LTS router board. We can see that in the middle of the PCB we have the Rockchip RK3328 SoC. This is M35 64-bit CPU with 4 cores, and the clock can go up to 1.5 GHz. Next to it, we have DDR3 RAM. This is 1 GB of RAM. Speaking about the IOs, we have 2 Gigabit Ethernet ports. One is integrated and it is powered by the YT8511C, and the other one is USB converted by the Realtek RTL8153B. Next to it, we have a USB Type-C connector to powering on the board, a reset button, and a USB 2.0 port. We also have a microSD card slot connector just right here, and I believe this should be a 16 megabytes of NAND flash chip. Let's see, we do have a fan connector right here, the 3-pin for the header, and we have the 13-pin GPIOs, and it is unpopulated, so you may need to solder the header in order to use it. And as usual, we have 3 LED to indicate LAN 1 and system status. Now let's assemble the case and the router board and let's check it out. So we can see that this is the thermal pad. Let me just remove it. Alright, so we have 2. I think one is for the CPU. Very good. And the other one is for the RAM chip. I'm not sure if installed on the chip is a good idea or installed on the case is a good idea, but let's check it out. And now let's put it in like this. Alright. So with some small adjustment, the ball already inside the case. And lastly, push on this case and tighten the screw. And that's it. So we have the TF or the microSD card connectors, system LED, LAN LED, the one port, and then USB 2.0 port, reset buttons, USB Type-C, LAN, and one port. Very simple. This router board comes with 16 MB of NAND chip. So I'm not sure if OpenWRT is pre-installed, but let's just give it a try. So this is the cable from my PC. I'm going to connect it to the LAN port. And then I will need the cable from the upstream router. Okay, so the LAN port, and now the WAN port. And finally, the USB Type-C cable. Very good. It is powering up right now, and we can see that the system LED is now up and running. And here we can see that the LED of the LAN port is blinking. Let me see. Alright, so it is up and running, but nothing happened on the WAN port. And so far, only the system LED up and running. So let's go to the computer and check it out. So on the network connection, I can see that the connection is off, but there is no IP address, and I assume that OpenWRT is not pre-installed. So let's just go to the Orange Pi website and then go to the service and download and get the firmware for Orange Pi R1 Plus LTS. Let's see what do we have. Ubuntu, Debian, OpenWRT, Linux, Shortcut. I'm going to download OpenWRT, and here I want, of course, the stable release. So let's just download it and flash to our microSD card. Download anyway. Download completed. Now we cannot directly flash this image on our microSD cards, but we will need to extract it. So right click and extract here. So we will have a system upgrade image and check some file. Very good. Now let's go to root first. Click the select button and then select our firmware, which is this LTS ext4 system upgrade. Hit start, OK, and wait for it. The OpenWRT firmware has been written into this microSD card, and now let's insert it to the router. Make sure you turn it down like this and slot it in. Alright, so I'm not sure if you can see it. Yes. Now use your finger to put it in until you hear a click sound. That's it. As usual, let's connect the USB Type-C power adapters and check it out. Alright, we can see that the system LED is now blinking, and I am sure that OpenWRT firmware should be up and running shortly. Now we can go back to our computers and check it out. And yeah, this time we can see that the LAN port and the WAN port also lining up. So here we have a new network connected. Yes. And let's go to network connection again. And this time we have this Ethernet connection up and running. So we have 1 gigabit connections, and it is 192.168.2.1. So let's disable the other network connection that I have, and then let's go to 192.168.2.1, and here we are. There is no root password. That's good. So everything is very clean, and we have Docker pre-installed. So we have some sort of pre-installed package such as, let's see, mouse point. We have the custom command advanced reboot. We have Docker. We have a lot of pre-installed services such as dynamic DNS, AdBlock, band IB. We also have bandwidth monitors, watt card, add tools, and even switch. Alright, so we have a lot of stuff, SQM, QoS, and even QoS. So yeah, you have almost everything, every single package that you need. So as usual, let's give it a root password. And then let's change the hostname. And we put it R1 Plus LTS. Change the time zone as well. Asia's where it is. Asia to Ho Chi Minh. Okay. So in network interfaces, we have 2 network ports, 1 and LAN, and we have 2 physical devices with different MAC address. So let's connect to the router with added H and check it out. I'm sorry, .2.1 root. So we can see that the router is running Linux kernel 5.4 2021. Okay, never mind. H-top. Yep, we had 4 cores and 1 GB of DDR3 RAM. So now I'm going to run the very same test, which is the OpenSpeedTest. So make sure network interfaces, the global network option, packet steering, the enable. And then let's go to the network firewalls and make sure the shortwave offloading is still disabled. So now I'm going to run a 1-2 LAN throughput test, and we can see that the one port is in GSCP client protocols and it is in the 172.16.9.0/24 network. So here is the test servers on the one side, and let's go. We are running at 600 Mbps with no shortwave offloading. And let's see what do we have for upload. So for upload, we have higher throughput. It is 680 or actually 700 Mbps upload with 2 core reaching almost 100% usage. So to be sure, I'm going to open another tab in order to see the top result. Alright, let's see the CPU consumption. Let's go. So we are reaching 600 Mbps download with 57 or 58% CPU idle, 6 only about 40% load. And the same for upload, we have almost 800 Mbps. Alright, that is good. Let's minimize this one and run the iPub3 test. Before running the test, I will need to start the iPub3 server. It should be iPub3-h-d. Very good. Now let's open a new command prompt. Then go to, it should be iPub3 and iPub3.c and then that 172.16.9.31 Let's see. And this time we have a higher iPub3 throughput and we are reaching 873 or 885 megabit per second. So with iPub3 we have a higher throughput and still the CPU at around 57% idle. And we can see that it's almost reached 900, so 860 megabit per second iPub3 throughput. Let's run the test in reverse mode. This time T20-R. And now we can see that when iPub3 is running in reverse mode, it only have 560 or 550 megabit per second. Alright, that's good. Let's turn on the software offloading and see if there any improvement. Let's go to Firewall and turn on software offloading. Save and apply. As usual, let's go with the OpenSpeedTest. Refresh, start. This time we have a huge difference. We can see that the download speed reached 700 Mbps and the upload speed is reaching 900 Mbps. Oh, I see that it cannot make 900 Mbps, but 860 is quite good. Let's run it again. And we can see that the CPU idle is almost the same before the software offloading is enabled, but we have a higher throughput. Let's give a try with iPub3. T20. Alright, this time we have 922 megabit per second, and shortly after that it dropped to 500 megabit per second. Something is wrong here. So we can see that the throughput is not stable. At first it go to 900 and drop to 200 and go back to 550. Let's run the test another time. Okay, so this time with software offloading, we can see that the throughput is not stable. Sometimes we can see that it's running 500 and then suddenly it's go to 800 and 900, which is not good. Let's run it in reverse mode. For reverse mode, we have a higher bandwidth, as you can see, and this time the throughput is also not stable. It is fluctuating between 790s and then go to 800s. So I think that the performance of this router is more or less the same with NanoPi R2S, but there is still some advantages on the R2S because it is not using the MotorComm chipsets. Alright, so for iPub3 with shortwave offloading enabled, we have unstable iPub3 throughput. In normal mode, it is around 660 megabit per second. And when running the test in reverse mode, we have 798 megabit per second. So I'm going to end the video here and we're going to test more in the next video. But before that, let's go to the RAV and see what do we have. So let me change it to, let's see, processor uses on the core, and then let's see interfaces, system load, memory, so unfortunately right here they only record bridge length, and for the processors 0, 1, 2, and 3, so they know CPU uses in total, and also no throughput for line 1, but we're going to take a look in the next video. Thanks for watching and see ya.